Hello, Sagar sir, are you there?
Yes, sir.
Okay, sir, shall we start?
Yes, you can start, but there is background noise from your end. Lot of noise.
Okay, एक minute. Hello, sir, is it fine now? Hello, Sagar sir, is it okay now?
Hello, Gaurav sir.
Yes, sir.
Please start.
Okay, sir. Good morning. Chair of SC Cyber Solutions, and also she is the founder of Women in Information Security. Ma'am, we are glad to have you here. I hope students will surely benefit from this lecture. Thank you. Students, before we start the lecture, I would like to just tell you that this session is split up into two sessions. So we'll have a 5 minutes break at around 11:20 till 11:25. Then we'll start with next lecture. Okay, thank you. Yes, ma'am, please continue with the lecture. Thank you.
Thank you, sir. Good
Thank you, sir.
morning. Let me share my screen. Is that visible?
Yes, ma'am.
Okay, perfect. Thank you. Okay, good morning. So, last semester we had done one aspect of cybersecurity. So, we had looked at the beginnings of cybersecurity, the basically individual security, what you can do for your accounts, what you can do to safeguard yourself, your family. But those were rudimentary. So, what we had discussed was password security, system security, the many social media accounts that you have. How do you keep those safe? Two factor authentication, those kinds of things. Today, we'll scale it up one notch and we'll talk about securing on a slightly larger scale. So, the other day, we were discussing one system or one user's security. We'll make it a little more today and we'll talk about security for a network, which is more than one computer. Now, a network typically, again, is something that we all have. Yep. So, not necessarily when we mean a network today, we mean two or three computers connected by a wire. Because, in fact, almost all connectivity today happens either over the wireless medium, so through your Wi Fi routers, through your hotspots, and with the cloud. So our network now is not physically restricted to ourselves, but the network now is much, much larger. Uh, Somebody has raised their hands. Is there something you'd like to say? Okay, I guess not. ठीक है. If you do, go ahead and do that. Otherwise, you can put in a message in the chat. So, anyway, given that our networks are not exactly one computer connected to the other, it is not exactly cell phones connected to each other. It is a combination of the whole lot. So it's hybrids. When we are talking about networks, though, what we are typically talking about in a computer sense is computers and the peripherals connected together so that they can talk to each other. They have some mechanism of communication and exchanging commands and data. How do they communicate? Different protocols exist, different languages exist that they speak in, and different kinds of communication are restricted for specific activities. So, let's say you want to transfer something from your cell phone to your computer. One way to do it would be to connect the cable between the two, putting them into a physical connectivity. The other way to do it would be via Bluetooth, or maybe share them over Wi Fi. Different kinds of methods have different security capabilities. Different kinds of methods have different levels of security, and some are definitely much safer than the others. Again, with something like connecting it via a cable, the possibility that if your computer has a malware, that malware is going to find its way onto the cell phone exists. This is something that does not exist over the Bluetooth connectivity in this particular scenario only. Again, it is something that might exist over the Wi-Fi connectivity. So the kind of mechanism you use for connectivity also is going to decide how safe your mechanism is. Okay. So typically we've got these home computer networks, which are not very large, not very complex, but they will most often have one single hub, one single base point from which connectivity is spread out. This single base point is very often the Wi-Fi router or the hotspot that the entire house uses. To this is connected multiple devices. Some could be laptops, computers, cell phones, uh, maybe TVs these days, printers, repeaters, a whole bunch of things will get connected onto all of these things. Again, each of these things has different levels of security, but the major security now in this case will happen at the central hub. So your router needs to be more secure and needs to be hardened to make the entire security of the house much more robust. Typically, this is how it is. So you'll have the internet through here. Let me see if it allows me to. Yes. So that's your internet, which is connecting to your modem, which is connecting to your router, which then passes on to your systems. Now, this again doesn't necessarily need to be wired, it can be Wi Fi. This connection typically is wired. This modem is connecting outside to the internet. So, all the dangers of the world exist here, which will find their way into your network through the modem, through the router, and then into your connectivity. Now, when I say all the dangers of the world, I know that some of them exist in social media channels, which we discussed last time. So I'm not going to bore you with those tips anymore. I might still do so. There's no certainty of it, but I'll try not to. Let's turn the pointer off. Yeah. These networks are also laid out in a specific logic pattern. And it's partly convenience, it's partly how do you lay it out. It's partly also how much can you save both in time and in effort, and of course in cost when your systems are connecting to one another. Now, typically a house network will follow a single kind of topology, whereas if you're looking at a larger scale, so if you're looking at the networks of an organization, networks of a college, they might use a mix of topologies to work better. The same thing is something that is done by your internet service providers. So they will use multiple topologies. Remember, when we are talking about a house network is not just your house network. Your house network is a combination of this being your internal house structure here, this being one portion of a network, and from here, this internet modem connection is actually much, much more complex because this modem is connected to your service provider. How is that service provider sending you bandwidth? Is it a wired connection? Is it a wireless connection? In most cases, this modem is getting connectivity through a wired connection. Now, again, depending on the technology used, this could be a CAT cable, this could be a fiber optic cable. As you know, most service providers today have shifted to a fiber optic cable. There are problems with fiber optic cables, as in, remember, fiber optic cables are glass, whereas your CAT cables are still copper wires that are copper and fiber wires that are wound together. So depending on the kind of technology you are going to be using, you will end up with different kinds of issues. One of our clients had a pretty major problem with their fiber optic cables, and this was an ongoing problem. The problem that they had was their factory was set up uh, in an open area, and the problem that they faced was they had a family of rats who would eat up the fiber optic cables. Now, something that we learned is that rats eat pretty much everything, but they seem to particularly like the taste of fiber optic cables. So, the major problem here was fiber optic was their best solution because they didn't want overhead cables, they didn't want cables hanging. Their machinery would get affected by those cables hanging. So, they had decided on fiber optics underground, which is how they are typically laid out. But then rats do find their way underground, and so the biggest problem was these rats. Eventually they worked out multiple solutions. So these the channels in which the fiber optic cables were put were filled with glass pieces and things of that kind so that the rats didn't venture there. They also found a family of cats who needed a home, adopted them, and kept them there. So their daily entertainment was Tom and Jerry scenarios, but it did sort out their internet problems considerably. So, when we are talking of networks, remember, it's never a single network that we are talking about. It is multiple networks connecting to each other to give us functionalities. If they don't exist, we have a problem. So, one network that you will have would be computer to printer. Now, you might have seen in many offices, in banks, and things of the kind, there is one single printer or two printers, and the entire office connects to it. So the printer is also connected to the router and is given an IP address to which it communicates. So anyone who wants to print just gives the IP address, and the print command goes to that machine. All of these methods are built into some kind of a logic pattern. That logic pattern is called your topology. Most often, it is not a physically visible uh, layout. It is much more a diagrammatic layout that is created. So it's schematic. It's how you know they are connected, but it isn't how they actually might appear to be connected. So let's give you an example right now. My computer is connected to three laptops, to three screens. Now, none of them are in the same logic pattern, as in you'll have the computer here, you'll have one cable, one monitor here, the other monitor here, the third monitor here. They aren't connected in the same order. So while they might be called monitor 1, 2, and 3, they don't seem to be monitors 1, 2, and 3 the way they are laid out or the way they are connected to my machine itself. In the same sense, my machine has things like printers and other kinds of devices connected to it. Now, all of these are connected out of one central hub, which then has multiple connectors coming to it. Again, the logic pattern is not always visible in the literal sense, but exists schematically. So, what we do end up with is these five mechanisms that are most commonly used. We've got the bus topology, which, as you can see, is kind of like you've got in a bus one entry point, seats on both sides, and one exit point. So it's a straight linear pattern. Your data is going to flow only along this channel and is going to be handed over to whoever is sitting there. Now, think of your data being transmitted as the conductor of the bus. As the conductor goes around asking, have you taken a ticket? That's the same way your data is going to be transmitted. So it gets loaded onto the conductor at the beginning. And as the conductor goes by, he will keep handing out data to whoever is there. So each of these machines will get their data. If any of these machines have data to give, they will hand it over to the conductor. Now remember, the conductor is not suddenly going to say, okay, let's say this is 1, 2, 3, 4, 5, and 6. He's got a 5, and 5 says, I want to send data to 4. The conductor is not going to take a U turn, give it to 4, and then move on to 6. The conductor is going to go to 6. If any other data needs to be handed over, he'll hand it over to 6, collect whatever data is required, U turn, and come back down. And then hand it over in this manner. Now, as you can imagine, this is not exactly the quickest process. It's also a little bit of a problem if either there is an obstruction over here. So let's say somebody in the bus has come with a really large suitcase and has dumped it in the middle of the corridor. You've got a major problem here. There's a bottleneck. Your data will not flow fast enough. Your conductor is going to have to navigate this data. Also, in the same sense, if there is a break over here, or if the conductor fails to function correctly, your data is not going to be transmitted. Same with the ring topology. It will flow in one direction only, so there are no U-turns here, which means that if one needs to hand it over to 12, it's going to go to all the other devices and then turn up. Again, if there's a break in this, it's just going to stop functioning. With the star, you have the most logical method that exists, or what appears to be the most logical method. Each of the devices is transmitting data to a central body. That central body will then pass this data on to whoever it needs to. So if system 1 is trying to pass it to system 5, then it's going to go on to the router, and from the router, it's going to move on to system 5. Here, you don't have a problem in the sense that not every device is going to receive the data. It's going to be passed on only to who wants it. Think of this mechanism as attendance being done in class. A roll number is called out, and that person raises their hands. Whatever needs to be given is handed over to this device. That roll number in all the mechanisms is called an IP address. An IP address is either a set of four sets of digits or 6 sets of alphabets and digits. In a common network, your IP address would typically be something like 192.168 something dot something. That is your home network. But your outside network will be different. So if you've got your cell phones with you, take a look at what your IP addresses are. You go into your settings and go into About Device if it's on an Android, even if it is on an iPhone, and you'll get your local IP address. That's the IP address that exists within your network. If you want to know what your IP address is for what you're looking at outside, remember this picture here? So we have one IP address for this communication. Think of it as a pet name, Ghar ka naam. This system has a name, this system has a name. These are 192.168 something or the other. This is what is outside. So outside you might very formally be called Miss Shweta Chawla, or something equally formal. While inside, what are you called? Shweta, come here. Child, come here. Idiot, come here. Whatever that might be. You might have multiple names depending on who is calling you. Here you have the formal nomenclature. This is outside. This IP address is different. This IP address could be 256 dot something, which is not possible. 256 does not exist. But it could be 230.148.63.192. So you could have multiple addresses. To find that, do a very simple search. Go onto your browser, possibly Google if that's what you are using, and just type out my IP address, and it will give you your external IP address. This is the IP address you are communicating with the world with. So back here you've got your individual IPs. So this is system 1, 2, 3, 4, 5, and 6, possibly. They could be named completely different. They could be named 24, 25, 26, 27, and so on. This is still connecting outwards. So, what actually happens is this could be your internal house network, but what you end up with is a hybrid network of this kind. This is your internal network. This router connects to the modem, connects to the internet, which then connects to maybe the other neighbor's house. Both of them are, you and the neighbor are both using the same internet service provider. सेम केबल, सो एक के घर पे इंटरनेट बंद हो गया, दूसरे के घर पे इंटरनेट बंद हो जाएगा if this cable is damaged. So this technology is what is actually put into use across the world. It's called the hybrid technology. Multiple connections of hybrid technology, multiple connections, in fact, of all of these kinds of technology put together give you this. And this, if you paid any attention, looks a lot like the internet or the pictures of the internet do. So we've got this mechanism. It's kind of like, when you go on a picnic and you're settling yourself down, you'll set up in the most effective method so that everyone can reach the food, or that the food is passed on in the most effective manner. That method is what we try to put into place on the internet, so that all data is transmitted in optimum fashion in the least amount of time, without data loss, and with the fact that some data is confidential. So not all machines need to get all the data that is being transmitted. That is what we are trying to take care of. So how does that happen? That happens by putting into place structures called layers of security. The entire logic of this happens with what is called defense in depth. So it's kind of an onion where you've got your data stored at the absolute center, and you're putting layer after layer of security over it to protect this data. Now, I can give you some very simple examples of this. The first is, let's say you have something extremely valuable in your house, physical something that is extremely valuable. Is that something that is going to be kept absolutely outside the house, near the window, in the balcony, wherever everyone comes and goes, so that it might go missing? Unlikely. It's more likely to be kept in the most secure room of the house, most likely inside a cupboard which is locked, the keys of which are kept most often in a secure location, or with a senior responsible member of the house. Think of that senior secure responsible member of the house as the guardian of the data. That is the same kind of logic that we try to put into place on the internet. So, in addition to having owners of the data, you have people who will safeguard the data, and you will have mechanisms that will put layers of security over the data that needs securing. Now, all data does not need the same kind of security. So some kinds of data will need very little security, while some kinds of data need higher levels of security. So again, let's give you examples. You've got, I'll give you 3 examples. You've got vegetables, you've got bank papers, and you've got gold. Which of them would get the highest level of security? You can type it out. Three things: vegetables, bank papers, gold. Who gets the highest level of security? Gold? Do bank papers need security? Yes. Do they need the same level of security? No. Vegetables, of course, don't need the same levels of security. Unless, of course, these days you're talking about Nimbu, and that is apparently phenomenally expensive. So maybe it does. But you've got these kinds of different products that require different levels of security. In exactly the same way, different kinds of data that we have on devices need different kinds of security. So let's say we have, again, I'm going to give you a bunch of examples. We have one cell phone which everyone uses to play games. Okay, that's the gaming cell phone in the house. Whatever games anyone wants to play is played on that device. You have one computer that is used for office work. You have a third device, which could again be a cell phone, which is used for classes, where only whoever needs to take a class will take it on that. Which of these devices gets the maximum level of security? The gaming cell phone, the work laptop, or the class cell phone? Which would get the maximum security? Yes, Nandita, go ahead. Okay, or not. ठीक है. So, in all probability, this laptop will. Yes, Ritika, at least as far as I know, the screen is being shared. Is there the problem with screen visibility?
Yes, ma'am.
No problem. Anybody else not able to see the screen? Okay, let me stop sharing and turn it back on again. Okay, is it visible now?
No, ma'am.
Huh, that's strange. Tells me it's visible. Sagar sir, is there anything that needs to be done to make it visible?
Mm, you can try. You can leave the meeting and join again.
We can see very well actually, ma'am.
Khare, ma'am. Can you see the presentation?
Yes,
Okay, so
absolutely.
some of
There's
you can
no
see it and some
Okay,
of
disturbance.
you can't.
then the problem is
That's a bit of a
students
nuisance.
who have low network, low bandwidth. If the bandwidth is low, then the screen may not appear on this. The presentation may not
Okay,
No,
is
appear.
it?
it's going
I'm
very
just assuming
smoothly.
it's
There's no
visible now
problem at all. For
because
those
there's
who have
nothing much
network, I
I can
don't
do
think
from
there's
my
a
end other
problem.
than make it,
And
other than
good
share the
morning,
screen.
ma'am. I
So
forgot to say hello to you.
it's okay.
I'm on
Now,
mute. Yeah. Okay. Yeah.
we assume that the work laptop is getting the maximum level of security.
It's absolutely clear. There's no problem.
Is that a correct assumption? Because it's a work laptop, we are assuming there is important work stuff happening on it, and so it needs security. What about the other two devices? You've got one where everyone is playing games, which means that You've got children, adults, and senior citizens possibly using that laptop, that cell phone. Are there possibilities that the cell phone can get infected and thereby turn on the camera and see everything that's happening? Yes. Same thing again with the class cell phone. The probabilities of all three devices being infected is accurate. There is a good probability there. But the probability that the damage to the work laptop and thereby to the organization is higher makes a lot more sense. And so that laptop would ideally get little more security or much more security depending on the work scenario. Now, security is, like I said, in multiple layers. So we layer on security, put different kinds of security in place, and then work at making sure that those layers of security do not fight with each other. And otherwise, that's going to be the other counterproductive. So those are things that are constantly tested out, those are things that are checked. You need to make sure that if one layer of security exists, the other layer that is over it is blocking the loopholes that exist in the earlier layers. You don't want major loopholes to exist through all your layers of security. So these are kinds of things that are studied in great detail before putting advanced levels of security into place. Not something that you need to worry about too much at this stage. That's usually the job of a professional. So this is also something that is called the castle approach. In fact, this is a kind of security that you will see in every fort that you will visit, particularly in Maharashtra. I am told in Rajasthan also, but then I've never been there, never seen them. But all the forts that you look at will have one central citadel, which is where your royal family and the courtiers will stay, with multiple levels of security around it. So, in fact, one of the most beautiful representations of this comes from the Lord of the Rings, the what is it? The final place where they have the battle, where Aragorn stays. That place, I can't remember its name. Anyway, is very very beautifully represented, with layer after layer after layer of security. So that one reason for this is that even if outer layers start failing, your inner layers are going to keep your data safe. We use exactly the same logic. Only instead of royalty, our concerns are with data itself. So keeping that safe is what we are interested in. You need to make sure that they are functional. You need to make sure that you're not duplicating layers. So you don't really want a situation where you've got, okay, I have one kind of security in layer after layer after layer. That doesn't help. Because if there is a mechanism to break that one layer of security, they'll keep repeating that mechanism and they will break through your security. So it is much more useful to put different kinds of security at different layers. Some more advanced, some more complex, but different kinds. So, what are the network security devices that we have? There are, like I said, multiple things that are done before this and after this. But let's start off with a very simple logic. Ask yourself, what do you need to protect? What do you need to protect from? And how much can you spend on it? Security, unfortunately, is always going to be expensive. But there are certain kinds of things that need additional security for which you just have to spend. So figure out the level of security you want to achieve, what needs protection, and what does it need protection from. Once you have those things in mind, your security can then be customized to it. When the security is being customized, we start off with what seems to be the most basic, the antivirus. Your antivirus is going to protect against the most widespread threat that exists. The most widespread threat that exists is that of malware. There's no question of it. You've got viruses, worms, trojans, adware. Sorry, somebody said something? Okay, possibly by mistake. Okay, so you've got stalkerware added onto it, which is particularly dangerous. You have ransomware that is uh, very, very problematic to corporates, even to individuals, but much more to corporates. Enough that it can pull down your entire system to the extent that you might end up having to shut business. So you've got these dangers that exist. They are each of the malware will do different things, and each of them will pose different kinds of dangers. Stalkerware and ransomware naturally are the most dangerous. Yeah, for those who can't see the screen, that is something you could try. And that's one of the things that security can do nothing about. So, low bandwidth is something that there is no way for security to deal with. But with low bandwidth, you end up with also having security complications because there are certain kinds of security devices that need additional bandwidth. And if that's not available, then those devices will not work at optimum levels. We'll get to that in a little bit. So back to our malware. Like I was saying, ransomware and stalkerware pose the greatest dangers that exist today. And I personally believe stalkerware to be much, much more dangerous. Also, because a lot of stalkerware applications are commercially available. They are absolutely available in Play stores. You can go onto any of the Play stores and buy them. And they are extremely invasive and intrusive. Uh, Besides, one of the things that exists in law is if you use a legally available device to commit a crime, that is still a crime. So the logic does not stand that, hey, this device is freely available and so I'm going to buy it. Or this device is, I can just go to a shop, buy it, and come and I can use it to commit a crime. It doesn't work that way. So if you do commit a crime using a stalkerware, or if you use stalkerware like applications for with the intent to cause harm, you are committing a crime. So that is always something you need to take care of. Ransomware, equally dangerous, but like I said, not as dangerous to individuals, definitely much more dangerous to organizations. So these are devices that we have in place on a typical network, but we'll deal with the antivirus first. The only job of the antivirus is to identify malware and to prevent that malware from causing you harm. One way for them to do it is to prevent the malware from infecting your device at all. The second is if an infected device is connecting to your system, it will scan it, look for malware. If it finds the malware, it's going to give you an alert. And then it's up to you to continue using that device or get rid of it completely. In certain cases, it might not be able to treat the infection, and so it quarantines it in the hope that at some other point of time they will be able to deal with the infection and they'll treat it and give you back the clean file. Or if the file is particularly harmful, they'll just erase that file altogether. So, an antivirus software's job is it's still called antivirus, even though its actual functionality today is anti malware, but the name has stuck, with viruses being the first kinds of malware that existed. So, the name has just continued. So, your antivirus software can be deployed at multiple levels. The first level, of course, is on an individual machine, as we discussed last time. Get it on your cell phones, get it on your computers. It will keep you safer. The second is you can get a network wide antivirus. This can be loaded either onto the server if you have one, or it can be loaded externally as a device onto your network itself. So anything going in and out from your network is going to be scanned by this antivirus software. Again, it is in some senses the most simple, and in other senses the most complex, because antivirus software work in multiple ways. One of those ways is they just look at a threat, they identify it, and they say, I know you because I have seen you earlier and you are a threat, and so I'm going to react to you. Or they will look at the way this thing is behaving and say the behavior is threatening, and so I'm going to react to it. Isn't that effectively the same kinds of things that we do? We know a threat. If you see a tiger in front of you, you're going to assume that the tiger is dangerous and react in that manner. If you are going to, in the same way, if you have earlier been bitten by a bee, the moment you see bees around you, you know you're likely to be attacked. You know it is something that might hurt you. So you react in that manner. It's the same way children react to fire. They realize that fire is dangerous, most often only after they have been burnt once mildly. But in most cases, there is this inherent instinct that says that that thing is dangerous.
Excuse me, ma'am, I have
And
a
so you
meeting, so
react to it
sorry,
in
I
that
have to
manner.
leave.
So,
Shweta, ma'am,
antivirus software identify
excuse,
malware based on multiple techniques and will deal with them in that sense. The next kind of security that's put into place is the firewall. And the firewall is a lot more advanced. Yes. Okay, I have a message, but I don't know who the message is from. Oh, yes, please. Thank you very much. So, your firewall is more advanced than your AV. It is not going to deal with malware at all. It is dealing with scary communications based on where the communication originates from and where the communication is going and the type of communication. So it is, let's say, it deals with suspicious activity in the sense that, again, let's give you an example. You are passing notes in an exam. Suspicious behavior? Yes. Known activity that is dangerous? Yes. We'll call it malicious. So, known malicious activity? Yes. Should it be blocked? Yes. Yes, from the security standpoint, beyond that, I'm not saying anything. So it should be blocked. It will be blocked by whoever is vigilating. That becomes your firewall. So your firewall says this is the activity that I am supposed to block. These are the parameters of that activity. And so I am going to block it. Now, this firewall is typically put into a place, let me, like this. This is your public network. Sorry, this is your public network. This is your private network. This is your home network. This is the internet. This firewall is going to stop all traffic coming from here unless it is traffic that has been accepted by your network. So if you have said that this is good, this is safe, it will let it in. If you say this is bad, it will stop it. The interesting thing is that every single computer device has 65,556 entry and exit locations. They are called ports. Each port has a purpose in life. Not all ports are used on a machine at all times. Typically, a machine will use about 1,000 ports. If these 1,000 ports are being used, it means 64,000 odd ports are not being used. By default, on a computer, all these ports are kept open. It is the firewall's job to block all these ports and say, okay, 1,000 ports is where data is being transmitted from, as has been authorized. Those 1,000 ports is where we will function from. So your firewall will give you specific kinds of data being passed through a specific port if correct permissions are given to that. So think about the firewall in some ways like the security guard at a bank. Can you just walk into a bank and walk up to the branch manager and go have a chat? No. You can go to designated windows without a problem. But the moment you start going beyond those designated windows, somebody is going to stop you, or at least ask you, why are you going there? If you give them a legitimate, logical answer, they'll let you through. If it's something that they find suspicious, they will stop you. On that note, I will stop here and we will take a 5-minute break and resume with firewalls after 5 minutes. Is that good, Sagar sir? Sagar sir? Okay. Maybe we ought to. Oh, well, I think we've got this 1 hour kind of thing with streaming, so we've got a few minutes more. ठीक है, I was just being overly cautious. Maybe Sagar sir will come back in a bit. So our firewalls are going to be doing kinds of stuff. Now, at one level, we are protecting against the data from the internet. At the other level, we also have data within our organizations that need protecting from one department to the other. If you've got a lab that's doing high end research, you don't want that lab open to the public. You don't want that lab open to the public within your organization itself. So you put additional levels of security over that level of data, that area. And that area in computer terms is what is called a demilitarized zone or a DMZ. It's an area with higher levels of security and an area that does not communicate as much with the other aspects of your network. Now, I know firewalls have sounded very, very complex, but they are not. You can get firewalls for systems that are very simple. It's going to ask you a question like this. It's going to say, I have this kind of a data that's coming in. It's going to port 51413. Should it be allowed? Should it be stopped? And these are pop ups that will keep coming every time you're sending out a new kind of communication. So let's say on the computer you've downloaded a game, and that game has certain access controls that it is going to take. It's also going to ask you if certain ports need to be opened. Now, there you can say no, you can block it off, and it gives you an additional level of security there. Much more complex, this is the Windows firewall, which will give you details of the various kinds of applications that run within it and what you want done. Now, if you've used a Windows machine, you know every time you connect to a new network, it asks you if it's a home network, a private network, or a public network. And if it's a home network or a private network, it's got one level of security. For a public network, it's got a different level of security. So that's the kind of thing that it is testing for. Okay, so we'll take a break now and resume. It's 11:25. We'll resume at 11:30.